by themselves, just like the metal balloons can be charged by themselves. However, if I touch the metal balloon, then any charges there will immediately flow through me to the earth. We will understand that later, because this is a conductor. Remember, the electric fluid is conducted by a metal, but not by a non-conductor. So with this, it's more difficult. Even if I kiss it and touch it, it's not clear that I can take all the charge off. In fact, by doing that, I may even make it worse. Let's hope that it is not charged too much, and let's approach it with this glass rod and see whether I can convince you that indeed it's coming to the rod. Not because of the free electrons, but because of that process. Oh boy. Huh. And it should also do the same with rubber, I hope. Now, if it were negatively charged, it may go away. It does go away, so it is negatively charged. You see that? By touching it, I actually probably charged it, and there's not much I can do about it. Very difficult to get charge off. I already had a suspicion when I approached it with the glass. It was too eager to come to the glass. Still negatively charged. That's the way it goes. It's not because the demonstration fails, but it's because the balloon is charged and doesn't want to give it up because it is a non-conductor. Friction can cause electric charge. And that's exactly what happened when I touched this balloon and tried to discharge it through friction. I may actually have charged it. If I take these party balloons that all of you may have seen, and you just rub them on your shirt, on your trousers, they stick to my hand. They have charge on them. Whether it's positive or negative, I don't know. I don't even remember. It's not important. And so when I bring them to my hand is not a good conductor. But you get induction, this phenomenon that we just discussed. And so the two attract each other. The positive and the negative side attract each other. And you can stick them on the ceiling, or you can stick them on the board. You can decorate your room that way. It's very pretty, isn't it? All of that you can do now because of 802. Now, these heavy balloons may be a little bit more difficult. Also, I'm wearing cotton. If you wear nylon or polyester, it's much better. It's much easier to get... Oh, that's good. That's a nice one. I think we need a blue one. There we go. So you see, friction causes electricity. That's, of course, why the silk, when we rub the glass, and the cat fur, we rub the rubber, then we create charge on one. Of course, if you make the glass positively charged, your silk will be automatically negatively charged. When you comb your hair, you may have noticed with dry weather that you hear some cracking noise. Cracking noise means sparks. And you will learn all about sparks in this course, though not today. But you can hear it if you're very quiet. And as you do that, you charge the comb. I can hear the cracking. Interesting. So the comb is now charged, probably, so am I. And there it comes. You see? It's not as good as the glass, but same idea. If you take your shirt off and you make it dark in your dormitory, and you stand in front of a mirror, an amazing experience. And I'd be happy to do it for you because, but I told you I already wear cotton and it doesn't work with cotton so well. You really have to do it with a nylon shirt. And when you take that nylon shirt off, not only do you hear the cracking, but you actually see the glow of these teeny, really little sparks. You actually are like a light bulb. It is an experiment that you cannot miss. And I would suggest you try that this weekend. And do it with a friend, that's even more fun. We all perhaps remember when you just walk around, do your normal things during the day. There are rugs in rooms, and you want to leave the room, and you touch the doorknob, and you get a shock. It's a spark that flies over. It's the electricity. Even when you touch a person, you sometimes feel this shock. When you cook, and you take saran wrap of these rolls, the damn stuff just doesn't want to come off, because as you roll it off, there is friction, and it gets charged, and it often gets crumbled up. And it's very bad, very difficult to handle it. You've all experienced that. Also, cellophane around boxes with chocolate, the same thing happens. As you take it off, you charge it, whether you like it or not. I now want to do an experiment, and I need a volunteer. I need a student who actually is wearing, preferably not all cotton, but I think, Simon, you have a beautiful, wonderful nylon parka. So if you are willing to sacrifice a little bit for the sake of science and come over here and sit down here, just relax. Make sure that your feet are off the ground. Okay. So what I'm going to do now, Simon, I'm going to beat you with a cat fur. And as I beat you with cat fur, you will get charged. And since I don't want you to be the only person who suffers under this experiment, I will also stand on an insulated stool. So if you become, for instance, positively charged, I don't know whether it's positive or negative, I would get the other amount of charge. So we share in the charge. And as I beat you, you will charge up more and more, and I will charge up more and more. And then we will have to convince the class that we are both charged. And we will do that in a way that will be hopefully rather convincing.